Hello, my dear children of class 11 science. Today we start with another new chapter under unit number 10. See, we are in unit number 10 as for class 11 syllabus. And the unit that we are dealing is called oscillation and wave. And in this unit, there are a number of chapters. So in the last class, we completed one of the first chapter of this unit, simple harmonic motion. Okay, now the chapter which we are going to start, important not only for this particular chapter but equally important for the remaining chapter to be discussed. Okay, and that is waves. The chapter name is called waves. So we start today with this chapter called waves. Now the term wave is very common that we use. Okay, now we usually have understood like wave is like somewhere like a nature like somehow like this way and all. Okay, now as per the term wave is concerned, wave is actually a disturbance. So just writing a point, wave is simply our disturbance. Wave is simply our disturbance which transport energy, momentum. We transport energy, momentum. Disturbance that transport energy, even it transport momentum also. Not only energy, it will transport momentum without the transport of matter. Without, this is important to be noted down, without the transfer of matter. So a disturbance which transfer energy, okay, without a momentum, without transfer of matter is simply called as what? Wave. Now this transfer of energy takes place when the particles of the medium, so try to understand, the particles of the medium are set in oscillation or vibration. They set in what? Oscillation or what? Vibration. That means when the transfer of energy is concerned, when the transfer of energy is concerned, energy transfer takes place actually by the what? By the vibration. Let me just the word vibration or oscillation. Vibration or what? Oscillation of particles. Vibration or oscillation of what? Particles in a what? Medium. Where these particles will not get transferred to other end, but simply this transfer particles, okay, with the vibration of this particle transport the energy to the other particle. So in this way the wave can simply propagate in the form of what? Disturbance. Okay, in the form of what? Disturbance. So this is the concept of what? Wave. Now when wave propagates in a medium by the vibration of particle, such type of wave is also known as progressive wave. What wave? Progressive wave. So I am just trying to define called progressive wave. Progressive wave. The progressive wave is nothing but a wave which propagates in the medium by the vibration of particle. Okay, a progressive wave is simply a wave which propagates. Which what? Propagates. The wave which propagates in a medium. In a what? Medium by the what? By the vibration or oscillation. By the vibration or oscillation of what? Particles. By the vibration or oscillation of particle. And such type of wave that is defined which transfer energy by the vibration or oscillation particle, okay, is usually called as what wave? Progressive wave. Now this progressive wave, when it propagates in a medium, as I said, the particles of medium are always set into oscillation or vibration. That's why depending upon the direction in which the particle oscillates or vibrates, the wave, this particular wave can be classified into how many types? Two types. So wave, as for the classification is done into how many types? Two types. So we come to the types of wave. The types of wave, and we call these types of wave as types of progressive wave. Okay, now there are two types of progressive wave as we can define. One is called transverse wave. Yes, children, you have learned this concept in class 10 also, but we learn in more details. One is called transverse wave. And number two wave that even propagates due to the vibration of medium particles is called longitudinal wave. What wave? Longitudinal wave. So wave as a progressive wave, which we can classify depending upon the vibration of the medium particle is concerned, there are always how many types of progressive wave or wave simply called wave can occurs two types. One is called transverse wave, one is called longitudinal wave. And children, this progressive wave can also called as mechanical wave or also called elastic wave. Also called mechanical wave or elastic wave. Okay, so transverse wave can be a mechanical wave also or progressive wave, and longitudinal wave can also be called as a mechanical wave or progressive wave. Okay, now we discuss in detail about the transverse waves. What wave? Transverse wave. Now to define transverse wave. Now when we say that the progressive wave is a transverse wave, this is one of the type of progressive or a type of wave, okay, in which the medium particles, so try to understand, this is the medium particles oscillates or vibrate along the direction, along the what? Direction perpendicular. The word perpendicular is also called normal to the direction of propagation of what? Wave. Suppose if the wave is propagated in one direction, but if the particles vibrate or oscillates perpendicular to the direction of wave, then such type of wave is called transverse wave. See example, suppose the wave is propagating in this direction. This is the direction of propagation wave. But if the particle vibrate up and down, see the particle vibrate up and down. So it's oscillating in such a way so that this direction of oscillation is perpendicular to the what? Direction of propagation wave. I can say this is the direction of what? Propagation of wave. Direction of propagation of what? Wave. Now consider the wave is propagating in this direction with this arrow, and these are the particles which are vibrating, oscillating perpendicular, because the angle will be how much degree? 90 degree. Vibrating perpendicular or normal to the direction of propagation of wave. And such type of wave which is generated is called transverse wave. What wave? Transverse wave. Now to give you the example of transverse wave, so there are many examples that we can see of transverse wave. But one of the common and good example of transverse wave is the vibration of the wave which is generated due to the what? Oscillating what? Rope. Oscillating what? Wave. Rope, sorry. So for that, let me just take a rope which is fixed at one end. So this is the fixed, this is the rigid support, and the one end of the rope is fixed at one end. So this is a rope. This is simply a what? Rope. Okay, so this is a rope which is connected with the fixed end. Now this is usually the rope which is connected horizontally. This is connected what? Horizontally. And this is the case where the rope is not generating any wave. Okay, not generate any what? Wave. But you know what happened? When this one end of the rope is simply get disturbed. When you make slight disturbance from one end, then that wave, that disturbance can pass to the other end also. That disturbance can pass to the other end, means there is a transfer of energy takes place from one end to other end. But this transfer of energy takes place due to the vibration of what? Mediums. Okay, medium particle. But this vibration takes place exactly perpendicular to the direction of propagation. And such type of wave is called transverse wave. That's why when one end of the horizontal rope, this is a horizontal rope connected with the hook of this rigid support, okay, and the other end, means this end is moved up and down. If you moved up and down, if you get a slight disturbance from this end, okay, then what happened? The wave which propagate in the rope along its length, along the length. But how it propagate? It propagate this way. This type of nature occurred by the wave, okay, along the direction of propagation. So when the wave is propagating in this direction, okay, but the particles in the medium which are vibrating up and down, this is vibrating perpendicular to the direction of propagation wave. So the nature of the wave occurs this way, and such type of wave is called transverse wave. So in this case, what happened? You are disturbing from this end. So from the other end, you are making the wave to be disturbed. Okay, this rope to be get disturbed. So one end you against the rope get disturbed, then this wave, the particles of this medium vibrate perpendicular to the direction of propagation wave, and that particle only transfer the energy to the other particles, and the other particle also get vibrate perpendicular to the direction of propagation. So with this vibration, keep on vibrating of particles, one particle, vibrating particle, transfer energy to the neighboring vibrating particle. Okay, so in this way the wave propagate in a direction perpendicular to wave. See, wave is propagating in this direction, the particles vibrating up and down. That's why from this end, if you make a slight disturbance produce slight disturbance, then this disturbance can only advance in the forward direction, in the direction of propagation of wave. But how the particles are vibrating? Perpendicular. And such type of wave we generate is called transverse wave. That's why if you make some mark if you make some mark in the rope, okay, you will see that that mark get vibrate perpendicular to direction of propagation wave. So that also makes the wave which propagate under this case is a what wave? Transverse wave. Now for example, sound can also travel in the form wave. The sound wave can also be a what wave? Transverse wave. And light can also travel in the form wave. And light wave are also a transverse wave. Remember this, and you learn in detail in class 12. So light wave are electromagnetic waves, but these electromagnetic waves like light wave are also transverse in nature. Now in transverse wave, children, when we come to the transverse wave, the position of maximum displacement takes place in the upward direction, and that position of maximum displacement in the upward direction is called crest, and the position of maximum displacement in the downward direction is called torque. That means if you have to express this crest and torque, so that there is a diagram which I have drawn. This is the nature of transverse wave, okay, where this graph which has been plotted is on the basis of displacement time graph. Time is passing out and the wave is also propagating in this direction, and from this point also the wave is vibrating up and down. But this vibration of maximum amplitude or maximum displacement takes place on the positive side or on the upward side, and this maximum displacement of these particles in the upward side is called crest. This is called crest. Similarly, the particle vibrate with maximum displacement on the negative side, okay, on the downward side, and this is called torque. So in case of transverse wave, we can always measure the crest, torque, even like this is called crest, and even we measure this is called torque and all. So when wave from a given source propagates by vibrating the particles perpendicular to the direction of propagation wave, the particles, okay, start vibrating perpendicular to the wave, but there are the particles which have a maximum displacement on the positive side or on the upward side, that is called crest. This displacement is positive, this displacement is negative, and if the particle acquire a maximum displacement on negative side, is called torque. So that's why in transverse wave crest, torque are always formed, okay. Now in transverse wave, the distance between two consecutive crests, see one first crest on another crest, that distance, if you measure, this distance is actually called as wavelength. This distance is called what? Wavelength. So if you measure the distance is called wavelength. Even if you measure the distance between two consecutive torque, then this distance is also called wavelength. This is also called what? Wavelength. So in transverse wave, the distance between any two consecutive crest or any two consecutive torque is also called wavelength. So corresponding to wavelength, we can even measure the time period. And time period means also the time taken between to have two consecutive crest or two consecutive torque is called time period. Now this graph as you see is the displacement time graph. Time is along x-axis and displacement y-axis. So we can even measure the time period between two consecutive crest and two consecutive what? Torque. Okay, so we can measure a wavelength, we can measure the time period in case of transverse wave. And when you know the wavelength, we can even measure the frequency. So these are the terms that we define also. Okay, but in case of transverse wave, the distance between two consecutive crest or two consecutive torque is called wavelength, and the distance time taken to have two consecutive crest or two consecutive torque is also called what? Time period. Now the question arises out here is, in what type of medium this transverse wave will produce? Now basically transverse wave can produce only in solid and on the surface of liquid. It also occurs in the surface of liquid. But in solid, what type of solid? The solid which is rigidity, the rigid solid. That means transverse wave produce in solid only when that solid is rigid. Okay. Gas has no rigidity, as you know that. That's what transverse wave can never produce in what? Gas. In liquid, the transverse wave produce, but not inside the liquid. It will form only on the surface of the liquid. That's why children remember this. Transverse wave can occur in solid, which are rigid, and look only on the surface of the liquid, not inside the liquid. And transverse wave cannot produce in gas. So these are the explanation of transverse wave. Now next wave we have called longitudinal wave, and that you learn in the next YouTube video.